For students who've studied integration, this should be a great question for them. It says the graph of the curve with equation y equals 16 over x squared minus x over 2 plus 1. Okay, that's shown below. X is greater than 0. We can see that. It says the finite region R bounded by the lines x equals 1. So that's my vertical line, x equals 1. And the x-axis, okay, we know that, the x-axis, and the curve itself are shown. So that's our area in green. The curve crosses the x-axis at the point 4, 0, okay? So our question is going to be to find the area of that, and it's going to be to do that firstly using the trapezoidal rule. It gives us this table to fill in. So we have some values already. When x is equal to 1, y is equal to 16.5. When x is equal to 1.5, y is equal to 7.361. So we put in 2. For x, we get 4 for y. We put in 2.5 for x. We get 2.31. And that is our table complete. So we have all of our relevant x and y values. We get 5 marks for that. So it's a relatively easy, straightforward start. We're now to use the trapezoidal rule using these values in the completed table to find the approximate value for the area of R, giving your answer corrected 2 decimal places. So on page 12 of the table book, we'll see our trapezoidal rule. So it says the area is approximately equal to h over 2. Now, students can get a little bit confused because the h is the width of the intervals and the y values are the heights, with y1 being the first height, y2 being the second, yn being the final one, and yn minus 1 being the second last one. So for students who are familiar with this and have practiced it, I would suggest it's straightforward enough. But for students who are trying to figure out on the day, you can see how they could make mistakes. So in this case, the width is actually a half, 0.5, because it's the gap between 1 and 1.5, between 1.5 and 2. It's the gap between the x values. So it's 0.5 divided by 2. y1 is going to be my first height. So this is my y1. yn is my final height. That's my last one. And then it's plus 2 times the sum of the remaining heights. So y2, y3, y4, y5. And of course, this is y6, but y6 is also going to be yn minus 1, my second last height. So y2, y3, y4, y5, y6, but that is yn minus 1. So now at this stage, you have to be careful to work out the answer, but it's approximately equal to 11.8775. Okay. And because we're asked to round it to 2 decimal places, well, we don't want to give any marks away. So we're going to get 11.88. We don't know, is it centimeters or meters or anything like that. So we'll say it's unit squared for 10 marks. So like that, you don't want to end up on 9 marks for not having units squared or not having your rounded correctly. So make sure you end up with full marks after doing the hard work. We then use integration to find the exact value for the area of R. So we're going to integrate. It's a definite integral question. Our limits are going to be 4 and 1, 4 being my upper value of x, 1 being my lower value. We have to integrate 6 all over x squared minus x all over 2 plus 1 with respect to x. So that's the dx. So what's going to happen there? Well, in this case, I'm going to be if you just to do one little part here, if I just take this off to the side, if I'm integrating 16 over x squared with respect to x, this is where people could go wrong. That's integrating 16 times x to the power of minus 2 with respect to x. So our rule for integration, of course, is that we're going to add 1 to the power and divide by the new power. So when you add 1 to minus 2, you're going to get minus 1. You're going to divide by the new power. So you're going to have 16x to the power minus 1 divided by minus 1. And that's what we get here. So we end up with minus 16x to the power minus 1 minus, similarly here, we had x to the power of 1 over 2. So we add 1 to the 1. So that's what's going to be happening here. We're adding 1 onto 1 to get 2. We divide by the new power. So when I divide x over 2, when I divide that by 2, I'm going to get the 4 underneath the line here. So I end up with x squared over 4. And when I integrate 1, it's going to become x. I must apply my limits 4 and 1. So I put in my 4 for x as my upper limit. I'm going to be subbing 4 in first, in for x. And I'm going to then get my answer here for that limit of 4. I'm then going to do the same thing for 1. So I'm going to be subbing 1 in for x in all of these parts here. And then I'm going to subtract one bracket from the other. So I'm going to subtract the number I get using the lower limit from that of the higher limit. And I'm going to get an answer of 11.25 units squared. And that's the exact area under the curve. And it's one of the uses of integration. So that was 10 marks. So we're nearly here with the question now. We just have one last part to go. Find the percentage error between the approximate and the exact values. So the percentage error is going to be the error over the actual multiplied by 100 over 1. So our approximate was the 11.88. The exact was 11.25. The error is the difference between the two. That's 0.63. Percentage error is error over actual multiplied by 100 over 1, 0.63 over 11.25 multiplied by 100, and that will give me 5.6% as my percentage error. And that was 5 marks. So as I said, I feel for students who know their integration, that was a very straightforward question. And of course, everyone I think would have seen integration at some parts, but some, at this stage of the year, but some students may not have focused on it. And it shows the importance of really being familiar with all parts of the course. So you don't have to, not to find yourself in a situation where you couldn't do the easy question.